Lesson 1, Laws of Exponents. In this first lesson of Unit 4, we're going to spend some time reviewing the laws of exponents. The laws of exponents are something you've seen since grade 9. They're summarized in the table below. Let's go through them one at a time. The first rule is the multiplication rule. This tells us that when we're multiplying powers, if the bases are the same, we keep the base and add the exponents. For example, we multiply a to the exponent m by a to the exponent n. Because the bases are the same, we keep that base and add the exponents, so our expression is a to the exponent of m plus n. And you can see an example of that over here. We're multiplying 5 to the exponent 4 by 5 to the exponent 2, so keeping the base of 5, we add our exponents to get 5 to the exponent 6. Next up, we have the division rule. When dividing powers, as long as the bases are the same, we keep the base and subtract the exponents. For example, a to the exponent m over a to the exponent n, keep the base of a and subtract your exponents. So the new expression is a to the exponent of m take away n. And you can see an example of that over here. We're dividing 4 to the exponent 5 by 4 to the exponent negative 3. Because you subtract the exponents, your new exponent will be 5 take away negative 3. That turns to 5 plus 3, which is why we get 4 to the exponent 8. Thirdly, we have the power of a power rule. Whenever you have a power to another exponent, you keep the base and multiply the exponents. In our example here, we have the power a to the exponent m, and all of that is raised to the exponent n. As the rule suggests, we just simply multiply the exponents, giving us a to the exponent of m times n. In our example, we have the power 3 to the exponent 4. All of that is to the exponent 4 again. So we use our power of a power rule to get 3 to the exponent 16. Next up is our rule regarding negative exponents. Whenever you have a negative exponent, by taking the reciprocal of the base, that will make the exponent positive. For example, here we have the base a raised to the exponent of negative n. Taking the reciprocal of a, we get 1 over a, because recall, everything is always over 1, even though it's not explicitly shown. So after taking the reciprocal, our exponent of negative n becomes positive n. In our numerical example, we have the base 1 over 2 to the exponent of negative 3. By taking the reciprocal of the base, our exponent becomes positive. And finally, the zero exponent rule. Any base, regardless of what it is, as long as it's raised to the exponent 0, will always equal 1. This is shown here. A to the exponent 0 is 1, and in a numerical example, we have 35 to the exponent 4, all to the exponent 0. Using our rule, that expression will be equivalent to 1. And generally speaking, everyone, please always express final answers using positive exponents only. Let's practice. This would be a great time to pause the video and try all of these examples on your own. I'll be going through them momentarily. So when you're ready, click play to resume. Alright, let's begin. In example 1a, we're multiplying powers. So we have x cubed y squared multiplied by x squared y to the 4th. Using our multiplication rule, as long as the bases are the same, we keep the base and add the exponents. So we do this for the x, and we also have to do it for the y. And that's going to be your simplified final answer. Part B, now we're going to get some practice using the division rule. So what I like to do in questions like this is simplify coefficients, then simplify powers with the same bases. For example, I begin by looking at the coefficients. Here I have 2 in the numerator and 8 in the denominator. So that's going to reduce to a simplified fraction of 1 over 4. Then, after doing that, I have to look at my a's. So as you can see here, we have a to the 5th divided by a to the exponent 2. Using your division rule, you keep the base, subtract the exponents, giving you a to the exponent 3. And finally, we have to simplify the b's. So we have b to the exponent 3 over b to the exponent 2. Once again, you keep the base, subtract the exponents, giving you b to the exponent 1. Now, generally speaking, we don't write exponents of 1, so I'll just rewrite this as 1 over 4 multiplied by a to the exponent 3 multiplied by b. Moving on to example 1c. So anytime you're multiplying powers, don't forget to multiply coefficients as well. That's actually a common mistake. So in this example, we should begin by multiplying the 9 and negative 4. That'll give you negative 36. Now that we've taken care of the coefficients, go ahead and multiply the powers using the exponent rules that we just discussed. X cubed multiplied by x squared gives you x to the 5th, and there's no other y, so just simply write it down. Halfway there, moving on to part D. So here we have the expression 5 n to the exponent 3 m to the exponent negative 4 all to the exponent 3. There's nothing to simplify inside of the bracket, so I'm going to go ahead and apply the exponent. Now the common mistake here is to forget to apply the exponent to the coefficient. So I'm just going to show my work here. You have to apply the exponent to everything inside of the brackets as I'm writing down here. All right, 5 to the exponent 3, that doesn't mean 5 times 3, that's 5 times 5 times 5, 3 times for a total of 125. Then we apply our power rules. N to the exponent 3 to the exponent 3, that's the power of a power rule, so we multiply the exponents, and we do the same thing for m. You'll notice we have m to the exponent of negative 12. We're going to use our reciprocal rule here. Now the good news is we don't have to flip the whole expression, we just move the m to the denominator. What I mean is this. You can think of this expression as being all over 1. Anytime you have a negative exponent, just simply take the power that's negative and move it to the other side of the fraction. So if you move it to the denominator, it'll become positive, and vice versa. So final answer is going to be 125 n to the exponent 9 all over m to the exponent 12. Part E, very similar to the last one, but we have a negative exponent now. So I'm going to go ahead and use the power of a power rule by multiplying the exponents. So we have here x to the exponent negative 4 multiplied by y to the exponent negative 6. Similar to before, all of this is over 1. Now both powers are negative, so let's bring them both to the denominators, and that'll give us a final answer of 1 over x to the 4th multiplied by y to the 6th. Now notice you're moving both powers to the denominator. That's going to leave you a factor of 1 left over in the numerator. All right, part F. We have to divide powers, but before we can divide them, we have to apply the exponent to the denominator. Don't forget BEDMAS. You have to do exponents before division. So that's going to give us negative 8x to the negative 4 divided by 4x to the negative 4. So I squared the 2 to get 4 and used the power of a power rule to get x to the negative 4. And now we simplify just like we did in example 1b. Negative 8 divided by 4 gives you negative 2. And then if you look at your powers, notice that we have the same power in the numerator and denominator. So they just simply reduce and leave us with a final answer of negative 2. In example 2, we're asked to convince ourselves that x to the exponent 0 is in fact 1 by using our division rule for exponents. Here we go. There's many ways to approach something like this. You can think of this sort of like a mathematical proof, but in a much less rigorous way. I'd like you to consider the following. Let's take the number 25 and divide by 25. I hope you'll agree with me that this is equivalent to 1. So we've created an equation here, 25 over 25 equals 1. I'm going to rewrite 25 as a power. So 25 is itself equivalent to 5 to the exponent 2, and I'm just going to replace 25 with 5 to the exponent 2. On the left side of the equation, let's simplify it using the laws of exponents. So notice that we're dividing powers. We have the same base, so we're going to keep the base and subtract the exponents, giving us 5 to the exponent 0 equaling 1. And we're done. This was just a nice little example to convince you that anything to the exponent 0 is in fact 1, and just be aware that it comes from the division rule for exponents. And to wrap up this lesson, we'll do example 3. These are slightly more complicated power rule examples, but still within our grasp. This would be a good time to pause the video, try it on your own, and click play when you're ready to resume. Okay, let's get started. There's many ways to approach questions like this. What I'm going to do is simplify what's inside of the brackets first. BEDMAS tells us to do brackets before exponents, but keep in mind you could actually do the exponent before what's in the brackets and then simplify after. It'll work out to the same thing. So in this first example, I'm going to simplify inside of the brackets first. 6 over 3 reduces to 2. X to the negative 5 over x to the negative 7 will give us x to the positive 2. This came from keeping the base and subtracting the exponents. And finally, y squared over y to the 1 is just y. All of that is to the exponent negative 3. Now I apply the exponent to everything. So we have 2 to the exponent negative 3 times x to the exponent negative 6 times y to the exponent negative 3. We'll have to continue up here. As before, all of that is technically over 1, so you can move all of those powers to the denominator like so. We have 1 over 2 to the positive 3, x to the positive 6, and y to the positive 3. This is just our reciprocal rule for negative exponents. And finally, you should simplify where you can. 2 to the exponent 3 will give you 8. Remember, that means 2 times 2 times 2, not 2 times 3. So final answer, 1 over 8, x to the 6, y to the 3rd. Moving on. In part B, it's very similar to the last one. It's all to the exponent of negative 3. Just to show you a different way of doing this, I'm going to use the reciprocal rule in a different way. What we can also do is take the reciprocal of the fraction inside of the brackets, and that'll make the exponent positive. Look what happens. By taking the reciprocal, the numerator becomes the denominator, and the denominator becomes the numerator, just like this. And now that we've taken the reciprocal, your exponent becomes positive. What I'll do next is simplify inside of the brackets. So 75 over 25 gives us 3. M squared over m to the negative 1 gives us m to the 3rd. And n squared over n to the 5th gives us n to the negative 3. All of that is still to the exponent 3. I'm going to do 2 steps here. I'm going to apply the exponent of 3 to everything, and I'm going to bring that negative power of n to the denominator. So this gives us 3 to the exponent 3, which is 27. That's 3 times 3 times 3. M to the exponent 3 to the exponent 3 is m to the 9, just multiplying exponents. When we move the negative power of n to the denominator, we're going to get n to the positive 3, but then raise that to the exponent 3, you get n to the exponent 9. That's going to be our final simplified answer for part B. And lastly, we have one more over here. You can approach it like we did in part A by simplifying inside of the brackets first. Actually, I think I'll do that for this one. So inside of the brackets, the only coefficient we have is 2. X to the negative 3 over x to the 3, you have to subtract your exponents, giving you x to the negative 6. You subtract the exponents of the y's, giving you y to the positive 6. All of that is to the exponent negative 4. Now we can apply that negative 4 to everything in the bracket, so that's 2 to the exponent of negative 4, x to the exponent of positive 24, and y to the exponent of negative 24. Remember, all of this is over 1, and we'll bring our negative powers to the denominator. So that's going to be x to the positive 24 all over 2 to the exponent positive 4 and a y to the exponent of positive 24. Simplifying now, we have x to the 24, 2 to the exponent 4 will give you 16, and that's going to be multiplied by y to the 24th. And that's going to be our final simplified answer. That completes lesson 1 of unit 4. You've been assigned the Laws of Exponents worksheet for homework. Be sure to try that out. And that'll wrap it up. Take care, everybody.